So today I'll be talking about types of bonding and types of structure together with types of intermolecular forces between molecules and atoms. So I'm going to start off with bondings. There are three types of bondings: ionic bonding, metallic bonding, and covalent bonding. The first one is metallic, and the second one is ionic, and the third one is covalent. What you need to know about metallic bonding is that it only occurs between metals, not non-metal and metal. It only occurs between metals, just metals. So how it occurs, its metallic bonding is the electrostatic. It is the electrostatic force of attraction between cations and delocalized electrons. The simplest way that you can remember it by drawing, visual memory is actually quite good for a lot of people. So for example, if I draw for calcium, calcium is a group 2 metal. So if I draw, I have, because calcium donates 2 electrons, it forms, calcium donates 2 electrons, so the electrons are delocalized. For each calcium atom we have 2 electrons. These are the cations for calcium atoms, and we have the delocalized electrons. So there is a very strong bonding, metallic bonding, between these delocalized electrons and calcium atoms. Okay, so now the second one that we're going to look is ionic bonding. It occurs between non-metals and metals. It is a strong electrostatic force of attraction between two oppositely charged ions, because metals give electrons, so they form 2+ positive ions, whereas non-metals, they gain electrons, so they form negative ions. I usually do drawings to help myself learn things quickly. So if we look at magnesium, which is a group 2 metal, and oxygen, which is a group 6 non-metal. So how will they form? Because we only need to show the outer electrons, magnesium has 2 electrons in its outermost shell, so it goes 2 electrons, whereas for oxygen it has 6 electrons in its outermost shell, and the 2 it gains from magnesium. So I'm going to do it with the opposite diagram, or opposite symbols. So this is how we're going to draw for ionic bonding. The last and the third one is our covalent bonding. Covalent bonding is the bonding between 2 non-metals sharing an electron. So the covalent bonding is the electrostatic attraction between 2 shared pair of electrons and the nuclear bonded to the atom. So how I'm going to, because there is no non-metal or metal, or not just metals, because if there are like 2 metals, they'll definitely form metallic bonding, whereas if there is non-metal and a metal, they will obviously form ionic bonding. But the only way to remember covalent bonding is that it only forms between 2 non-metals, because they need to they need to complete their outermost shell. So because they can't gain it from the non-metal, so they need to share the pair of electrons in order to get a complete outermost shell. So for example, I'm going to do it with carbon dioxide. We know that carbon is a group 4 non-metal. So it has 4 atoms and it needs to form 4 more. So in order to do that, it will form 2 bonds with oxygen. 1, 2, 3, 4, 5, 1, 2, 3, 4, and it shares 2 electrons with the carbon. Same goes for this one. And as you can see that it has formed a covalent bond between two oxygen atoms. What difference does it make with the different types of bondings? That gives different types of structure that we have. There are two types of structure that you need to know about. The first one is giant, and the second one is simple. Okay, now that we know that metallic bonding, ionic bonding, and covalent bonding, they are all very strong forces of attraction between the atoms, so of course they'll definitely form giant bonding. Metallic bonding gives us giant structure, whereas covalent bonding, ionic bonding, they all give us giant structures. Simple structure is formed when there is very weak intermolecular forces between molecules, not atoms. So we're not talking about atoms. I'm not talking about a bonding between carbon or oxygen together. I'm talking about bonding between molecules. Like if we have this whole molecule, there is a bonding, there's a force between many molecules together. So with the molecules forming together, the force between these molecules gives us a very simple structure. So that this refers to the intermolecular forces. So the simple structure refers to, and we have three types of intermolecular forces that we need to know about. The first one is, second one is induced, and the third one is hydrogen bonding. How do we get our induced dipole-dipole intermolecular force, which gives us a very simple structure? It never gives us the giant structure. So how do we get our induced dipole-dipole? So for example, I have a bromine molecule. This is a molecule. So for example, we know the bromine atom is a negatively charged atom because it gains an electron. It has 7 electrons in its outermost shell, so it needs one more. It gains one more, so it has a charge. We have electrons. Because they are sharing, there is a covalent bond between the two bromine atoms. So the electrons sometimes get uneven distribution of the electrons. Uneven distribution of electrons gives us a slight negative charge on one bromine atom, because most of the electrons have now shifted to this side of the bromine. The uneven distribution of the electrons causes the second bromine atom to gain a slight positive charge, which means that this induces the neighbor molecule or the neighbor atom to gain the same negative slight charge. Because it is induced, it is not permanent. It is induced because of the uneven distribution of the electrons. So that is why we have an induced dipole-dipole intermolecular force, which can be easily broken. It is not that strong. Hydrogen bonding is the most strongest intermolecular forces between out of the three. It forms between north. You can remember that it only forms between north attached to hydrogen. It's nitrogen, oxygen, and fluorine attached to hydrogen. As you might already know that water molecules have hydrogen bonding, it's because we have an oxygen atom which has a lone pair of electrons, so it has a slight negative charge on it, and the oxygen and the hydrogen that are already bonded to it, they have a slight positive charge, so that's why it is easier to form hydrogen bond between the other water molecules, for example. So for example, if I have two water molecules, because I have a slight positive hydrogen and a slight negative oxygen, there are two water molecules, so they can easily make a hydrogen bonding.